This video mainly shares with you the incredible bridge construction technology in China. We learn about China's bridge building technology through the 5 most famous bridges in China. The first one, the Sidu River Bridge. This is a bridge built on the Grand Canyon. This bridge was once known as the highest bridge in the world. The bridge is 1,105 meters long and 24.5 meters wide, and the height drop from the top of the tower to the bottom of the canyon reaches 650 meters. The bridge is located in the dangerous canyon, and the span between canyons is 900 meters, which makes it extremely difficult to build. As we all know, the first step in building a bridge is to set up a main cable of the bridge. There are 2 traditional construction methods of long-span suspension bridges, which are the manual pulling method and the helicopter lifting method. The bottom of Sidu River Canyon is 500 meters away from the bridge deck. There are cliffs on both sides of the strait. It is impossible to use the traditional manual pulling method. In addition, the canyon is windy and the wind direction is erratic, and the dragging cables will cause helicopters to fall into flight safety hazards. So it is not suitable to use helicopter lifting methods to erect cables. So Chinese engineers have come up with the idea of using rocket throwing to erect bridge cables. In this way, it took only 4 seconds to complete the cable throwing task. The application of rocket launching technology to the construction of the pilot cable of suspension bridges to fill the gap between construction technology of pilot cable of the suspension bridge in complex terrain with high peaks and deep valleys has become a classic moment in the history of bridge building. Second, Jiming Bridge in 3 provinces. This bridge is very remarkable and can be called a miracle in the history of bridges in the world. As we all know, when a general bridge is built, the first step is to build piers and then lay box girders on them after being supported by piers. But this bridge is not that simple to build because you need to cross a Grand Canyon, and there is an abyss under the canyon. There is no way to build piers at all. Moreover, this place is located in seismically active zone, and the mountain rock strata are very unstable, so there is a high risk of landslides. It is precisely because of the extremely harsh environment that this bridge attracted the attention of foreign engineers when it was built, and they all want to see how China built the bridge in the canyon with such a huge span. Engineers set up supporting platforms at both ends of the canyon, divide the main arc ring into several sections, and adopt the cantilever pouring method of the arc ring, pouring concrete step by step from both sides to the middle, and then bonding them together. The through arc bridge has a net span of 180 meters. With the support of this arc, the bridge is built on it. The whole process needs to be constructed by cable hoisting end of the main cableway. German engineers bluntly said that only China can build such bridges in the world, seeing from a distance. This arc bridge is like a rainbow across both sides of the canyon, and its momentum is very magnificent. The third, Pingtang Bridge. This is a bridge with a total length of 2,135 meters and a main tower height of 332 meters. The height is equivalent to the height of a 100-story building, and it is known as the overpass in the cloud. The bridge is designed as a 3-tower cable-stayed bridge, which is praised by experts in the bridge field as the tallest and most beautiful bridge in the world. When building such a high bridge, the strong wind in the sky is an interference factor that cannot be ignored. The Tacoma Strait Bridge in Washington State, built in the United States in 1940, was blown down directly when the wind speed was only 67.5 kilometers, which became a serious lesson in the history of global bridge engineering. The height and length of Pingtang Bridge far exceed that of the Tacoma Strait Bridge, but the bridge built by Chinese engineers can easily resist strong winds of about 14 to 15. Fourth, Shinkang Bridge. This is a super long steel truss suspension bridge built at high altitudes and high earthquake intensity zone. The bridge is 14 and 11 meters long and adopts a steel concrete structure, which is known as the first bridge in Sichuan and Tibet. As we all know, general bridges have to go through inspection tests after construction and before opening to traffic. Past the test, it can be confirmed whether the structural construction of the bridge is guaranteed safe and whether the mechanical performance, bearing capacity, and other indicators of the bridge meet the design requirements. Therefore, to test the safety of the bridge, engineers found 48 large trucks loaded with loads, with a total weight of an astonishing 16 and 80 tons. From the experimental data, it can be seen that the bridge meets the determined design requirements. The 48 heavy trucks successfully proved the reliability of the test results of Xinkan Bridge. China's adoption of this test method has attracted strong attention at home and abroad. Foreign engineers have expressed their feelings about the strength of China's bridge construction technology, and the title of infrastructure fanatic deserves its reputation. Fifth, monorail bridge. This is the world's tallest spiral disc straddle monorail bridge, which is known as the world's first high-speed rail. This monorail viaduct is 4,200 meters long, and its structural materials are mainly steel beams, which look very magnificent. There is a spiral orbit, which is even more amazing. The spiral track has a diameter of 60 meters and a slope length of 620, which is a 3-story semi-spiral structure. The column is 46 meters long. When the train travels to spiral section, it was surprised by the spectacle of high-speed rail climbing the stairs. When the train passes the spiral steel bridge, it is as thrilling as riding a roller coaster. This wonderful design is the first in the world on rail transit bridges. Watch this review of China's amazing bridge construction technology and tell us what you think. Enjoy!